Some stories in aviation history are so significant, so tragic, that they literally change the way we fly. Today, we're going to talk about one of those, the catastrophic story of Japan Airlines Flight 123.
520. That's the number of people who lost their lives on August 12, 1985. What was supposed to be just a short, routine flight from Tokyo to Osaka turned into an absolute catastrophe. And to this day, it is still the deadliest single aircraft accident the world has ever seen.
So the big question is, how does a modern jumbo jet on a totally normal flight just fall out of the sky? Well, the answer is pretty chilling. Because this wasn't some random sudden failure. It was the result of a hidden flaw, a ticking time bomb that had been set 7 years earlier.
To really understand what happened here, we have to go back. Not to the day of the crash, but all the way back to 1978, to what seemed like a totally ordinary repair job.
So on June 2, 1978, this very same 747 had a tail strike during landing. Basically, the tail scraped the runway. It damaged a really critical part called the aft pressure bulkhead. Now, you can think of this bulkhead as a big, strong, dome-shaped wall at the very back of the passenger cabin. Its whole job is to keep the cabin pressurized so we can all breathe at 30,000 feet. It's incredibly important.
So a team from Boeing was brought in to do the repair. The procedure was very specific. You take one continuous metal plate, a splice plate, and secure it over the damage with 3 rows of rivets. Simple enough, right? But that's not what they did. Instead, they used 2 separate, smaller plates. And this one change meant a huge section of the repair was held together by only a single row of rivets.
And that right there, that was the fatal flaw. Instead of spreading the immense forces of pressurization across 3 strong rows of rivets, this botched repair funneled almost all of that stress onto that one single, much weaker row. It created a hidden weak spot.
So how weak are we talking? Well, the investigation later found that this faulty repair job reduced the bulkhead's resistance to metal fatigue by a staggering 70%. It wasn't a question of if it would fail, but when.
Okay, let's fast forward to the day of the accident. It's August 12, 1985. JAL 123 takes off from Tokyo and starts its climb, with that 7-year-old flawed repair hidden in its tail.
So for 7 years, over more than 12,000 flights, every single time the plane took off and pressurized, tiny little cracks started to form and grow along that weak line of rivets. Then, on this flight, just 12 minutes after takeoff, as the plane passed 24,000 feet, it finally gave way. The bulkhead just ripped apart.
The bulkhead failure was just a trigger. It set off this devastating chain reaction. The high-pressure air from the cabin blasted into the unpressurized tail like a bomb going off. It blew the vertical stabilizer, the big fin on the tail, clean off the airplane. And in doing so, it severed the hydraulic lines for all 4 of the aircraft's control systems.
And just like that, in a matter of seconds, the pilots had nothing. The rudder, the ailerons on the wings, the elevators on the tail, all of it was completely useless. They were flying a 747 that had become, for all intents and purposes, uncontrollable.
What happened over the next 32 minutes is, frankly, one of the most incredible stories of airmanship you'll ever hear. The crew fought with everything they had to fly a plane that was simply no longer flyable.
With its tail gone, the plane was unstable. It entered this wild, porpoising motion called a phugoid cycle. Imagine it climbing steeply, losing speed until it nearly stalled, and then violently nosing over into a dive, picking up terrifying speed before pulling up and starting the whole horrible cycle again.
And if that wasn't bad enough, it was also doing something called a Dutch roll. The tail was fishtailing left and right, and the wings were rocking back and forth. So you've got the plane pitching up and down violently and swinging side to side at the same time. Just absolute chaos.
So with all the normal flight controls gone, the pilots had only one tool left: the engines. They tried to use what's called differential thrusts, powering up the engines on one side to try and turn, or adjusting power on all 4 to try and control their altitude.
And we know from the cockpit voice recorder, they understood this was their only hope. You can hear Captain Takahama on the recording telling his crew they have to try and control the plane's pitch with engine power alone.
But here's the thing. Accident investigators later put seasoned pilots in simulators and recreated the scenario. And their conclusion was chilling.
trying to control both of those violent motions at the same time, using only the engines. It's considered practically impossible for any human pilot to do. They were truly fighting an unwinnable battle. Despite their absolutely heroic efforts, the plane eventually crashed into a mountain. But the investigation that followed would change aviation forever, making sure a disaster like this could never happen again.
The investigation was crystal clear. It all came back to one thing: that botched repair on the pressure bulkhead 7 years earlier. That single mistake was the root cause that started the entire chain of events. The tail blowing off, the total loss of all 4 hydraulic systems, it all started there.
And as a direct result, the entire industry changed. Sweeping new rules came into place to make sure that a single point of failure, like a bulkhead rupture, could never again lead to a total loss of control. Things like stricter repair standards, new designs to protect hydraulic lines, and even something called hydraulic fuses that can isolate a leak to save the rest of the system. You see, this disaster completely shattered a core belief in aircraft design. Everyone assumed that having 4 separate, redundant hydraulic systems made you safe. JAL 123 proved that if you run all 4 of those systems through the same tiny part of the plane, one single event can take them all out. It forced a total rethink of what redundancy and fail-safe design really mean.
So, could something like this happen again today? Well, thanks to the hard lessons learned from JAL 123, it is extremely unlikely. Modern aircraft are specifically designed to survive an explosive decompression, with critical systems protected and separated so they can't all be knocked out at once. The story of JAL 123 is, of course, a terrible tragedy, but it's also a powerful reminder of why maintenance and repair standards are so critical. And in a way, it's a testament to a crew that fought against impossible odds for 32 minutes. Their struggle and the lessons learned from that day have made every single flight you take